Okay, so you are doing your pre-calc. This homework is a review for your next class. Your next class, we're going to start functions, a unit on functions. So we're just warming up. What I want you to do, I'm going to do the first one with you and then you're going to fill it in, is I want you to determine the type of function that you have on the left. Then I want you to look at the domain, which remember is for what x values does this graph exist, and the range, for what y values does this exist. All right, so here we go. Function. I look over here. Cubic, constant, square root. All right, I stopped right here. This is a constant. This is the equation y equals 2. Is a constant. I can have constant y equals 2. I could have 4, for example. Okay, does this graph exist? Well, for all values. I can write it all real numbers. That means all real numbers, or I could write negative infinity to positive infinity. Either will work. Now range is different because this graph, no matter what x is, y is 2. So it's y equals 2. I could write it as 2. Okay. Actually, but this is our new format, so that's what we want to be able to recognize this on tests and quizzes. Okay, so please fill in the rest, and I will see, you'll check that in class tomorrow. All right, so stop, finish up, and then come back. All right, you've come back. We're going to review linear functions. Now, we're going to start with, in all of our functions, we're going to start with degree, the degree of the function. The degree equals 1. All linear functions have a degree of 1. Because if I have y equals mx plus b, a linear equation, this is really x to the first power. And what defines the degree in an equation is the highest power or exponent. Okay? So we have a degree of 1. Okay, that's our. The second thing about the function is it comes in 3 forms, which we went over the very first day. All right? We have slope intercept form. Then we have point slope form, and we have standard form. So I'm going to give you what those are, just to remind us. When we have slope intercept form, we have y, this is our favorite, y e mx plus b, because it's easy to graph. Point slope is y minus y1 equals m times x minus x1, and I like this one when I have a point and a slope and I want to find an equation. I can use that formula. Standard form, ax plus by equals c. When I'm going to start with the intercept. Y intercept, so it have a positive 3 slope. 3 over 1, up over 1. Okay, and that, there's the line. Next equation, have a negative 2/3 slope. So change in y, negative, change in x is 3. Double check, and I say, okay, if I do that, am I getting that's negative? Because as x goes to infinity, the graph is decreasing, and that's what it means. All right, last one, intercept, y-intercept of 5 and 5/4. So I go 5 on the y-axis, 1, 2, 3, 4, 5, and 4 on the x-axis. And I go to the left, 1, 2, 3, 4, because I know that I'm going to end up with a positive slope. Okay, there we go. 3 equations of lines. Now, before we go further to other types of equations, let's talk about transformations. And if you remember, transformations have to do with A, H, and K. Okay? A appears to the left of x, outside of parentheses, if there are parentheses. What it does is it determines direction, and by the direction I specifically mean down, positive, negative, up, down, positive, negative. It also determines the width of the equation. Is it wide or is it? Now for linear and quadratic equations, remember we have number narrow, fractions fatter, quadratic equations. If you remember that. Okay, but that's what determines That's what A does. H appears in parentheses with X. And it determines horizontal shift. I'll put it in other words, left and right. Left. Does this function go left or right? K is added on to, usually at the end, added to the function. It's not in parentheses. And vertical shift. Determines vertical shift. Up or down. Okay? Up or down. And different from direction where I mean or flipped over the underneath the x-axis. By up or down, I mean, does the whole graph go up or the whole graph going down? A little bit confusing. Sometimes we call this flipped for A. So now we're going to look at these different functions and talk about A, H, and K and what they do to the graph. So the first thing you want to do is identify A, K. So A is to the left of X, outside the parentheses. A is -1. And what does it do? It flips the graph over the x-axis, and it's a 1. So no change in width, because it's not increasing, or it's 1, which is the base function, the parent function. Okay, let's look at H. H is here. Now, I'm going to give you the parent form. Y equals A times x cubed plus k. Okay, that's what the general form of it is. And remember, this is always x minus thing. And because it's positive, it's really x minus a -3. So what is H? H itself is -3. And what does that mean? It's -3, so the graph shifts left 3. K is -6, and what does that do? That moves the graph down 6. Let's look at this one. Again, A, H, and K. A, H, K. A is 2, okay? There it is. And what is it going to do? It's going to make the graph narrow, and it's positive to face upward, so up, above the x-axis. So it's I'm gonna try like up, if up, or positive. Okay, H, x minus what? H is 3. It's positive 3. And what does that do? Well, that moves the graph right 3. K is positive 1. It's added on. It doesn't change signs, so it moves up 1. Now, I'm going to give you standard form of this absolute graph is y equals a x minus h plus k. The form of this graph would be y equals a 1/2 square root x minus, always x minus h, k with x. And let's go back up to these notes and say parentheses with x, x minus h. Okay, so that's why we change the h, but we don't change the k because it's just plus. Okay, a h k, and I see that a is positive, so that's a square root function, and we'll get to that in a little bit. And h minus what? -2. So this goes above the x-axis, and it actually fractions with, don't make it fraction fatter, it's actually narrower. So that's a switch with the root functions because it's opposite of x squared function. So that's why that is that. All right, h is new. I'm going left 2. And k is 0. Nothing added on, so k is 0, so no vertical shift. Okay, let's move on. Again, you could always slow down, go back over something. Let's go on to the other side, quadratic functions. Let's start with degree. Quadratic functions have degree equals 2, okay? All quadratic functions are U-shaped. We also call that a parabola. Okay? When I say, by the way, back up to degree 2, y equals x squared is the parent function of a quadratic function. And it means that the highest degree of a quadratic is 2. And it can have plus 3x minus 7. You can have anything else to the right, but the highest degree is 2. All right. There are forms of a quadratic. You should remember this from last year. And they are vertex form, standard form, and intercept form. Okay? Give you the general form equation. Y equals a times x minus h squared plus k. And what does that give you? Well, that gives the vertex. HK is the vertex. We love, that's our favorite form. Okay? Standard form. That is y equals ax squared plus bx plus e. And what do you get? The only thing you get is there is the y-intercept. That's what you can find out from standard form. You can always change between these forms, okay, with algebra. Intercept form, if you remember, is y equals a times x minus p times x minus q. Okay? Now, what do you get there? You get p and q, opposite signs, are your x-intercepts. Okay? So, remembering that, these are all in vertex form. One of the things you can see up here is that no matter what form you're in, you do get the a value, all right, which tells you, am I above the axis or flipped? It tells you, am I narrow or wide? Okay? So for quadratic functions, for a, for the value a, we have numbers narrow, fractions fatter. Meaning if I have a is 1/2 here, that means fat fraction. If I have a is 3, it would be a narrow function. Fractions fatter. I'm trying to forget where I was. Okay, let's graph. First of all, we shift. And how all these shift. So let's draw the, in green, I'm going to write y equals x squared, which is your function, okay? This is your parent, and I'm going to draw it in green on all 3 graphs, parent. So, 0, 0. If x is 0, y is 0. If x is 1, y is 1. If x is -1, I square it. -1 times -1 is +1. If x is 2, y is 4. If x is -2 times -2 is +4. This is the parent. Okay, so I'm going to draw it 3 times. Okay, draw it quickly. Drawing it. There's my parent. We're going to watch the shifts. So over here I always start with a, h, and I say, okay, a is 1. K is -5. And this tells me that it has no flipped. That's the shift. That's the only shift. Left 5. So I take every point and shift it 3, 4, 5. And then I just, and the entire graph, left 5. Okay? Let's look at the next one. AHE, H, K. My done graph is going to be in blue. Okay? I have an A of -1. I have an H, x minus 8, and a K of 3. So this is going to be flipped because A is negative. There is no change because A is still 1. It shifts right 2 and it shifts up. The way that I like to do a graph is flipped is do a dotted line for these two shifts and then flip the whole graph. So let's do this first in red. Point and shift it right 2, up 3. I'm going to shake this point, right 2, up 3. Sorry, this point is right, there we go. Okay, and then they take this point and go right 2, up, oh, so I'm dotted, sorry, dotted, I meant to dot it, dot, 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 dot. Okay, I shifted every point 2 and up 3, but I flip it. What do I flip it over? I flip it. I'm actually just taking the graph and flipping it over its new origin. Okay? If I were to draw its new, origin or its new beginning, but I now have to flip the graph over this line, okay? Which is y equals 3. So what I do is I just take, I don't flip, doesn't flip, but I take this point and I jump over above, and so I go 4b. Okay? So take this point, jump over the new x-axis, because the whole graph up 3. So the whole x-axis showing down here. Graph is the correct graph with all of its shifts. Okay? Next one. I have A, H, and H. Have a positive A, so it's not going to flip. A is 1 fractions fatter. This is going to make off. H is positive 4, K is negative 1. So the shifts are, it's a fatter, it spreads out. It is a right 4 shift, and it is a down 1 shift. Okay? Now it's hard to do, I can't just easily do a graph. I would actually have to plot points. Okay, so let's see what would happen if I went right 4 and down 1. 1, 2, 3, 4. Be my new origin. I know I'm not going to go, I'm not going to flip because A is not, I'm going to have a graph, just kind of this point, that's fatter than the one before, that is shifted right 4 and down 1. All right, so that's a sketch and not a graph. Okay, quadratics, quick and dirty review. Square root functions. All right, start with degree. What is degree? All right, so I'm going to start with the degree, not of specifically square. The degree of all root, whether it's whether it's square root. When it doesn't say anything by implicit, it is a square root. But it could be a 3 or a 4 or a 5 here, okay? Function, degree of all root is a fraction. The power, that's what makes the root. The degree all squares, okay? This is square because this is 2, okay? Square is f, okay? So what I'm saying is that, remember, that x